G'day and welcome back to the shed. And I'm still working on this Columbus Model 90, built in New Zealand in 1945 and built to last. It's a very nicely made radio in a lot of ways. But if you watch part one, you'll know that I had a few issues with it. The transformer was completely burned out. It was toast, and I'm not 100% sure what caused that. There are various theories which I might discuss later. But by the end of part one, I'd got a replacement transformer thanks to Ron Pond here in Perth, and wired it in, and it was producing voltages in the right places. With the rectifier tube in place, I was getting DC, and that's about as far as I got in part one. Now I can't progress things any further really without having the speaker field coil in circuit. So I think the next thing to do is to take out the speaker, check out the field coil, plug it in, and I can continue to trace through the circuit and apply voltage to it. Hopefully by the end of this part we'll have it up and running. Maybe I'm being a bit optimistic there, but that's the plan. Anyway, let's get on with that. Alright, so let's get it out of the cabinet. Just held in with 4 wood screws here. Heavy lump. The cone looks good. It doesn't scrape. Oh, whole cone's loose. Okay. Nice that it doesn't scrape, but that's all going to have to be glued back in. What I'm more concerned about is the field coil, of course. That's interesting. The suspension on this cone is quite unconventional. In here we have this big spring arrangement. I guess that's springy steel. And it's held in by these clamps, so it's all adjustable. There's quite a bit of dust around the voice coil there. I'll just check if we have anything on the voice coil. Measuring about 2.5 ohms DC resistance across the voice coil. Of more concern, of course, is the field coil. Looking at it, there's no sign of burning or anything in there. Looks like these 2 wires here are the field coil. And there'll also be a humbucker coil in there somewhere. So these 2 outer connections here appear to be the field coil, and there is nothing. Nothing at all. Looks like it might be open. Gee, I've had enough of open coils in this radio already. I don't want an open field coil. Looks like I might be buying Dave Tipton that cruise after all. Someone's attached these horrible wires to it. I don't think they're original. Held together by masking tape. Triple sets of wiring. It looks like what they used to use for power cords in some cases. I don't know. I might just take the output transformer off just so I can see what's going on there a little bit better. It has nuts on the inside here, I think. Yes, there's a nut there, and I'm probably going to drop it. Nope. There's the nut. It's just hanging there fairly securely. And yes, this does look like these are the field coil wires, and that other thing here, that'll be the humbucker coil, no doubt. I'll just check it, but that's in series with the voice coil by the looks of things, so that's what it'll be. The field coil wiring looks alright, but there's nobody home. Nothing at all. Okay, well, I've drawn myself a little diagram and taken lots of photos. Not that it's that hard to work out, but just in case. So I'm now going to unsolder the field coil. Oh, hang on, that goes through here. Okay, that's one. It's the other one. Now, the voice coil braids and the humbucker coil. These screws seem to be tapped into this piece here, so there's no nuts to worry about. Oh, and they're really tight. Okay. Yep, that's one cracked. Try this one. Yes. Yes, and one more. That one I think I've done. Yeah. This one. Yep. Okay, and I didn't put the screwdriver through the cone, which is really nice not to do. And the last one. So there we go. See if it'll come out if it's... There's a humbucker coil. Now which way did that go in? I think it went in that way. Yeah, I'll check the video. And here we are. It doesn't look cooked. I can hope, I suppose, that the brake is near the end and just unwind it and have a look. Doesn't look terrible. And that one seems to be making contact okay. How about the other one? Oh look. Oh no. No, I thought I was going to be lucky there for a minute, but it is apparently attached. No, it's not. Oh, we might be lucky here. Okay. I'll just stick this down before anything happens to it. Not seeing anything. No, I'm not seeing anything at all. Who knows where the brake is in there? Could be anywhere. Well, once again the radio restoration community's come to the rescue, and none other than Dave Tipton has offered to rewind the coil for me. Of course, if you're watching my channel, you'll know Dave Tipton. He's got a well-equipped workshop in the heart of downtown Brisbane, and he's got a new coil winding machine which should be perfect for the job. It's no mean feat winding one of these things. They're typically over 1 kilometre of hair-thin wire, many thousands of turns, and it takes quite a bit of skill and the right gear to do it. So much appreciated, and I've packaged it up. I found the perfect box for it. I've got no idea what an Avanti Edistal Rost Fry is, but we must have bought one at some point. Anyway, I'm entrusting this to the tender mercies of Australia Post, and hopefully Dave will receive it sometime in the not too distant future. While the field coil's away with Dave Tipton, and I'm sure he'll do a great job on it, I'm just getting started on these capacitors. I've changed a couple of them so far, only 2, and I thought, well, the next thing I need to do is to pull out the second stage filter cap and change it. And because this chassis is fairly crowded, I'm going to mount the new capacitor inside the can of the old one, just as I did with the first filter cap here. So I've cut and labelled all the wires as usual, because I don't trust myself to remember anything these days. This time I did it a little bit differently. I just filed around the edge here until I was able to pop out this ring, and the rest of the insides came out. This bit broke a little bit, it has a contact on it, so I'll have to do something about that. Just pulled out the insides, came out in one lump, so that's all right. Shouldn't be touching that probably. So now I'm just going to mount, I think this is a 16 UF. It says 15450. It doesn't say 15450 watt. I wish they'd be more specific, but I presume that's 15 microfarads at 450 volts. So I'm going to put a 16 mic cap in that and mount it in the can and put it back in the chassis. I've also changed a couple of other capacitors, this one here, and there was another one somewhere, not sure where, down here, that's right, only because they were in the way. And one of them's this Ducon 25 mic. It actually measured at about 0.3 microfarads, possibly still alright. And we've got this solar capacitor, which is a 0.1, and it measured 0.1. So they're probably both okay. They're both paper capacitors, so I'm going to change them anyway because they're not reliable into the future. We have a strange mix of caps here. The Ducon solar, there's another solar there. This one here is a Sprague, and the electrolytic caps made by Mallory. So they've got quite a mix in there. Well, I thought I'd have a go at removing some of those cans, those 1UF capacitors that are leaking oil and stuff everywhere. There's one I can get to the back of here. It's just soldered into here. A couple of others are behind IF cans, so I'll have to take the cans off to get at them, but they don't look terribly hard. I'll just see how I go desoldering this, and I'll just increase the soldering iron temperature a bit. Bit of fresh solder there, and see if we can melt it. No, that's not going to happen. I'm going to have to get the other iron out. Okay, this should be hot now. Let's see how we go with it. It's oh, that's doing it straight up. Alright, I'll turn it upside down and we'll pull it out. Well, there it is. I'm told these things may have PCBs in them. I don't know if that's true or not. But I'll desolder it, take it out, and see if it might be feasible to empty them out and stuff them with some 1UF caps. I don't know why, but they just seem to be a unique part of this chassis, and I'm kind of reluctant to ditch them and put in modern caps. I think I'll just cut that. Okay, so I think that says you can clearly make out 5 and 400, I guess, volts. So does that mean that's a 0.5 microfarad? I don't know. RCNZ, so Radio Corporation of New Zealand. Okay, so it says 57 nanofarads, so that's more or less 0.057 microfarads. But looking at this, you have to get the light on it at the right angle, but it does say 5, and I kind of think I can make out a point. I don't think it says 0.05. Well, this is what came out of it, just a normal foil capacitor. That's the remains of the end piece. And this is just sticky grease, I think. Doesn't have any smell or anything like that. I think it's just grease or wax, very soft wax. So here's the can, and it's got some wax or fibrous material around the edge there, and I was going to pull it out, but I thought I'll leave it there. It'll provide some thermal insulation for the new capacitor when I put it in, when I'm soldering it. I don't want to get the can too hot. Looking at the end of this end is concave, and that whole lot was just filled with solder. Took quite a bit to melt it out, and I don't want to replace all of that, but I will solder it in pretty solidly and put a lead through to the chassis. Now the lead of that capacitor goes to pin 4 of the 6J8 here, and that is the screen grid. It is also, there's obviously no capacitor hung off that there in the schematic, but if you follow it around, it also goes to the screen of the 6K7, and here we have, this is marked as a 1.1 microfarad cap, and I remember that Steve said that all these caps were 0.1. However, this one clearly says it's a 0.5. Have I lost the writing of it? I think I must have cleaned it off. Surely not. That was silly of me. Anyway, you saw the video a minute ago, and it did say 0.5. That says 0.1. I can't see any other capacitor that it could be. There's nothing else here that could be a 0.5. So which way do I go? I think I'm going to put a 0.47 in that, just because it clearly did say 0.5 on it, even though the schematic says 0.1. I don't suppose that would stop the radio from working. I wouldn't think so, because it'll just be there to filter noise out of the screen grid. So I've got one of Carl's finest 0.47 mic caps here, and that will fit neatly inside if I can get it in there. It's a little bit tricky to get in because the lead doesn't meet the hole until the view is blocked by the cap. There we go. So now I've hacked a rough circle in out of this stuff. This is actually gasket material from a car. It would be handy to have a laser cutter about now. I could just whip up a cover plate for all of them, but I'm thinking, I'll put it the other way in, but I'm thinking if I push this inside and pull the capacitor back up on it, there we go, it's happening. Right, now if I pull that back up, that will sit like that, and it's not exactly the same as the original, but it's not bad. The other side can get bent over and soldered onto the chassis. Actually, if I push this in again, put a bit of super glue around the edge here, I think I can probably make it stick in place. And pull that back up, and hopefully that will stick. Well, there it is, soldered back in its place. I hope the 0.47 is okay in that position. I think it would be. There's only 6 more of these to go. Hopefully they'll get easier as I go along, and I think I've got 3 or 4 paper caps to change as well. Well, this arrived from Dave this morning. I opened it at the time, had a quick look, but I had to rush off to work, so I haven't had a chance to have a proper look at it, but I have opened it, and Dave has included a little note which shows the winding direction and which wires which I was a bit worried about, but that's handy. Thanks, Dave. And here we are. The long wire is the outside of the wind. I'll just take this off now. Oh, that's fallen off. That's all right. It was like that, I think. Just went like that. In fact, I'll tape that back on like that so I don't mess it up. And here it is. Woohoo! and yes, the longer wire. Very good. So now what am I going to do? I haven't finished the recap on the radio, but I'm pretty keen to find out whether we can get any signs of life out of this. I also haven't had time to do anything to the speaker, so I'm not prepared to put it all back together yet. What I'm tempted to do is to hook the coil up into the power supply circuit. I might even put in the output valve and see if we get any noise. I'll have to rig up another speaker, but that's all right. I can still use the output transformer and feed it through to another speaker, so let's give that a go. Now, we all know Dave's a pretty clever bloke, and you never know what to expect from him. I half expected him to leap up out of the box in hologram form and rewind the coil on my bench top, but that didn't happen. Hang on, what's that down there? There's something in the bottom of the box. Looks like a roll of film. This must be Dave's rewind. Let's just thread that up on the old projector and have a look.
So this is it here. He sent me the magnet, the humbucker coil and the field coil. So what I'm going to do is try and unwind this onto another spool. I'll be able to count the turns and I'll be able to work out roughly what the resistance should be, and hopefully it'll come out something close. It doesn't have to be spot on. It's not going to affect the radio operation that much. The main thing is to get the number of turns on here. I have the original coil mounted on this old winder here. That'll count the turns as I peel them off. I'm going to wind it onto this spool here. As I said, this is only going to go to where the break is, then I'll have to rethread it. It's finished winding. That's the number of turns. I'll set up to do the rewind. I'm all set up to do the rewind. I've programmed the computer here. I'm winding the wire off a spindle. It should be strong enough to pull that without breaking. Coming up to a turn. That looks good. Alright, that looks like it's going on pretty good. It looks about the right amount of wire. In fact, it's exactly on the mark that was there before. So I'll put a bit of tape here just to hold the loose end while I cut it and get it out of here. And I'll cover the rest of the coil with some mylar. And I'll pull that end of the wire out of the way and then put some tape on this side. That'll do. I'll take it out of the rig and I'll measure the resistance, see how close we are. I've cleaned some insulation off the end there. So I'll put my clips on here. There it is, 1486. So yeah, just that's exactly what I got actually, 148 something when I calculated it. Alright, that's good and exactly what I expected. So I'll put some fly leads on it and we'll be done. I'll put a bit of tape on it and that'll hold it, and I'll do a full wrap around. I have a bit of fish paper here. I'll just finish this off. Just make it look a bit pretty. There it is. Alright, I can send that back to Don. I think he'll be quite happy with that.
So that was pretty impressive. That was a very edited version. It took me a few minutes with a pair of scissors and some sticky tape to edit it down, but I don't want to steal Dave's thunder because he will be publishing his own video of this. So here we are. I've got it, the variac plugged in, the dim bulb's plugged into the variac, the radio's plugged into the dim bulb. I've got all my test leads taped down so they don't fall around and short or zap me. And over here I've used the original wiring harness for the output transformer. I've got the coil clipped to it. This meter will be monitoring the filtered B plus out of the coil. This one will just show me the unfiltered B plus coming out of the output valve off the first filter capacitor. I'm aware that this will not generate the proper inductance because I don't have the other pole piece on it. The other pole piece is fastened securely to the basket of the speaker, and that still has the cone in it because I haven't done any work on it. So I can't really put it onto that at this stage. The humbucker coil of course won't do much, but it's there because it completes the circuit through to the voice coil, and I didn't want to change the wiring on the output transformer. The only thing for it, I guess, is to put power on it and see if it goes bang. I'll put this on DC volts, he said. I'll put this on DC volts. Yep, there we go. There's a storm brewing outside. I wonder if that's an indication of things to come. Now, I'll feed the variac, set it at about 100 volts to start with. I need some voltage on it, enough to get the heater in the rectifier valve going. That's the only valve I've got plugged in at the moment. No output valve, no nothing. So here goes. We'll see if anything goes bang. Not yet. We've got some voltage coming up there. That's with, yeah, just on 100 volts. That's yeah, I'll put that back to 250 volt range. Oh, it's about 75. 72. They'll be pretty much the same because this is unloaded, so we won't see any voltage drop or any significant voltage drop from one part of the filter to the other. Alright, I'll put a little bit more voltage on it because nothing's gone bang. So upping it to maybe 150 volts. There we go. I've got 208. 209. I'll just bring it up to 250 volts DC coming out of the rectifier. And we should have pretty close to that there. Alright, well, nothing is smoking, nothing is going bang. So, what do we do next? I'm going to turn that off before anything smokes. The coil isn't warm or anything. Okay, what I could do is put the output valve in and just see if we get any hum from the shop speaker here, or any noise at all. So this is a F6 output valve. I've got no idea if it's any good, of course. I'm just putting it in here. And turning it on. And we have a little less voltage on here now for the 250 going in. In fact, I'll need to up that a little bit to get 250. We've got, yeah, 230s now, which suggests that that is drawing some current. And I heard a crackle from the speaker, just a small tick. And the voltage here is now dropping, which suggests maybe something's leaking, or maybe that output valve is starting to conduct a little bit more. I'm just touching the grid with the screwdriver here. Thought I might hear something, but I'm not hearing anything. Okay, I've turned it off again. I'm going to put the 6K7 preamp detector valve in. It's a bit awkward working upside down, but this way at least I can see if anything's getting hot or causing trouble or whatever, and it's easier to hook up the leads this way as well. So that's in. I'll put its grid on. Okay, so turning it on again. Again, the B2 plus, the filtered B plus is a little less than it was before for the input voltage, and I'll bring that up to 250. Just try touching the grid there. Nothing. Not a sausage. I just realised I made a silly mistake. I plugged the 6K7 into that position. It should have been the 6J7. I just didn't read my writing properly. So I'm going to put the 6J7 in there. I hope I haven't done any harm by plugging the wrong valve in there. Nothing went bang, and the dim bulb didn't go crazy. Okay, turning it on, this time with the right valve in the socket, and we'll just see what happens. Oh, I haven't turned the variac on. There we go. Went up to 300 and now it's dropping back. Still hearing nothing from the speaker. Ah, we have grid hum. What a beautiful sound. Okay, we're getting somewhere. So the amplifier stage is working. I guess I can probably plug in the rest of the valves and see if we get any reception or anything like reception. Okay, so all set up, plugging it in. And we've got quite a glow from the dim bulb there. It's dimming off and brightening up again fairly quickly actually. Better turn this on. We've got 259 volts coming up there. Full volume, still not hearing anything at all from the speaker. Not even the slightest hum. I'm getting grid hum there now. Not as much as I was before, but I've got the rest of the valves in, perhaps that's why. Okay, I don't suppose there's anything there. Hang on. That sounds like reception. It's full volume, but that is reception. It's working. Very faint. I'm thinking perhaps the dim bulb is a little bit too much restriction for it to work properly. I'm just going to try putting it on full power. Nothing seems to be wrong, so it's probably okay, I hope.
Through mismanagement. The hospital undertook what it called an independent
There we go, it's working.
Following Jackie's complaint. Sports coverage of the 2024 AFL season. Catch on the ABC listener. Singles kick up. Warner crashes the pack. Nick Remold style put down. Umpire says play on. Picked off here. Atkins to close. Looking snap in the Cats. Fills the man on the mark to go back a couple of metres and out.
Seems to be receiving right across the band. That's that racing station. It's about the last one I get.
$5. Icy Ultra. $6.50 and Ultra.
Well, I thought I'd better get on with replacing the rest of those capacitors. I'm sure there's a bit of leakage going on there at the very least. Now, the first two I want to replace are under the first IF can. The next two I want to replace are under the second IF can. So I've unscrewed this from underneath. Someone has worked on this before because the screws in the IF can were different to the others, and the coil is held into the can with this nut, so I'll just get that undone. And I hope that I can desolder those capacitors without causing any damage to the IF coil. It's proving a little bit difficult to pull up. I'm not sure why. Oh, there we go. Okay, so there's the IF, and under there is a solder for one of the capacitors, and under the other side here is for the other one. So I should be able to get to them now without doing any harm. I'm almost tempted to take this valve cap off and replace the wire. So I've got the big iron good and hot. This one doesn't have a thermostat, so you leave it on for a while, it just gets hotter and hotter. And that should do the trick, I think. I'll try poking that cap down with a screwdriver. Come on, let go. There we go. It's just plopped through to the other side. While I'm at it, I'll do this side as well. Okay. There we go. So both of them are popped out underneath. I will replace that wire. I'll just cut that off. And the IF can very sensibly has the IF frequency printed on it. I've got a piece of cloth covered wire which I took out of this radio. I think it was this one or another one, but it's the same sort of wire is used throughout this radio, so I'll put that in. It's multi-strand stuff, and I don't really like using the single strand. It does tend to break if you're not careful. I'll push this through here. And just take this one off. There we go. And I'll just tack it on here. There we go. And tuck it through that hole. Okay, so I'll see if I can desolder it. If not, I'll just cut the wires off. A bit of fresh solder on there might help. There we go. So I've cleaned it off, and this time I'll be putting a piece of sticky tape over the writing to make sure I don't accidentally rub it out. Last time I wrapped this in a cloth to pull the inside out and put it in the vise, and I think that must have just been enough to rub the writing off. So just looking at the schematic, and I've been poking around here a bit, I've identified it as this capacitor. That is the first one of the two I'm replacing, the oil-filled ones. Now this one goes to the second IF, sure enough, and also through a 1 meg resistor down to the power supply and this tap here. So I've checked all of that, and that's correct, so it must be this one here, and it does specify a 0.05 in this case, so the schematic matches what's written on the can. So I've prized the end out. It wasn't particularly easy. There we go. Alright, I'll give that a clean out and put a new capacitor in it. So I've got one of coils 0.047s here. Just see if I can thread that through. There we go. And I'll do the same as with the other one. I'll just put a little disc in there with the cap on it, pull the capacitor back, and that'll hold it in place. I don't think I bother with the super glue. I don't think it did anything. And there it is back in. So I'll just solder that in again with the big iron. Yep, doesn't foul anything. So I've just desoldered this second can. The writing on it is a little more smudged. I think it did say 5 on it, but yeah, there we are. I can just see a 5 there. So I'm assuming that's another 0.5. It goes to the other side of that IF. and also through this 24k resistor to pin 6 of the 6J8, which it turns out is the oscillator plate. Alright, so I'm trying to identify which one it is. The only thing I think it can be is this. It says here 0.25 UF, but there's a 23k resistor which goes up to the oscillator plate of the 6J8, and to ground. It must be that one, and it also goes up to the other side of that IF transformer there, so it has to be this one here, but this one says 0.25 microfarad, this one says 5. So again, I've got to choose. I don't really know what to do here. There's another weird thing too, I'll just show you that. It was also soldered to this 3.3 meg, is it orange, green? Yeah, it's 3.3 meg, if I'm right. Anyway, it was soldered to this, which goes across to this other capacitor here, which I think is attached to the other IF can, the second IF, and that is not on the schematic anywhere. It does look as if it's been stuck on later as well, so I really don't know what this is all about. I guess I'll put it back, but this is a later type of resistor than the other ones in here. It's not consistent with the other resistors in the chassis, so I think it has been tacked on later. So I'll ignore that one, and I think I'll put a 0.47 in this because it does appear to have been a 0.5. So here's the second one soldered in. I have put this resistor back. I've just tacked it on so I can easily remove it. And what I might do, assuming this still works, is just remove it and see what difference it makes. Okay, well that's all done. I've got everything hooked up again, so I'm just going to put it on dim bulb and make sure that it still works. And the dim bulb's doing as it should. Dimmed off. Should be coming up again any minute now. And this doesn't work terribly well on dim bulb, so I'll turn it up, but I don't expect to hear. Oh yeah, we've got some noise there, so I'll tune it.
We are chasing the WMRC on Belinda's word on the street, who reckons the councils are going to be slugged with an extra.
Okay, we have got some reception on dim bulb, which is well better than we had before. I'll take it off.
Rates are going up to 133,882, and if we keep on that cost of living theme, the Centre for Policy Development wants the federal government to implement $10 a day childcare. The think tank says that the scheme would cost the government $7 billion a year.
Yeah, unfortunate. After
Behavioural ecology, WA. Hello, Amanda. Hi. Have scientists always presumed that elephants have been able to talk with each other?
Well, I guess we know that they can communicate. Like we know for...
Well, I'm not sure about elephants talking to each other, but it does seem to be working, so that's good. Well, you've got to be happy with the way things are going with this one, really. There's a lot more to do with it, though, of course. I haven't finished changing the caps, and you don't want to watch me change caps for another half an hour, so I'll do that off camera. There's a speaker to deal with, and that's a job in itself. I haven't hooked up the Magic Eye yet. That's still got to be tried. I haven't even tried it on shortwave, and that's not to mention the cabinet, which is another job. So I don't know if I'll get that done in the next part, but I'll give it a red hot go. If I don't, this might be a 4-part series. It really has been a collaborative effort, this one. The radio restoration community has really come forward, with Ron supplying the transformer, and I've got knobs coming from Steve in New Zealand. They should be here soon, and a couple of lamp holders as well. But most of all, Dave Tipton for winding that field coil. That was awesome. He got it back to me in record time, and that allowed me to move forward with the project, which is great. So thanks, Dave. Now, there was a lot more to that coil wind than I showed you in that bit of film. Dave tells me there was quite a lot to it, and his video of the coil wind should be up about now, so do yourself a favour, check that out. It should be interesting, and it might give you some clues as to why the coil failed in the first place, which has been a bit of a mystery. Anyway, thanks for watching. I hope you've enjoyed this. We'll catch you in part 3 in a few weeks. Bye for now.